In this practical, in the second week, we are going to look at water level and storm surge characteristics that occurred in New York during Hurricane Sandy. Okay, what I'd like you to do is somewhere on your computer, I'm going to go in here, create a new folder. I'm going to call this SOES6011 Practicals. And you're going to use this certainly for the next 4 weeks. It's really good when you program to be as organized as you can. So I'm going to create a new folder called code, and I'm going to keep all of my MATLAB code in there, and another folder called data. So I've got those 2 folders there, and I'm going to use that for all of the next 4 practicals. Okay, what we can do now is go to Practical2 on Blackboard, scroll down, you can read a little bit about the practical there, and I'm going to download this template. Okay, so we're going to download that template. I'm going to go to downloads, copy that, and put it in my code. So over the next 4 weeks, all of my code is going to live in this folder, and then any data that I'm going to use in this folder, it's always good to be organized and separate out the code from the data, or else, if you can have a lot of data, it gets quite messy. Okay, so within MATLAB, you always work from a given folder. So I'm going to click on that folder and click on code. I've got my command window here, my workspace. Everyone has MATLAB laid out in a different way. I quite like to have my scripts laid out to one side of my command window. I want to come back to my command window and open up on the data. Okay, so you can go through and read through this. But essentially we're going to use tide gauge data from this NOAA website, and later on we're going to use meteorological data from a climate data store. Okay, so as I've said here, I've created this folder called SOES6011 Practicals. I've created a folder called code. I've put this MATLAB script within that code folder. You can check there. I've got another folder, data, which we'll use later. Okay, in each of the next 4 practicals, I always think it's good practice to start by clearing all variables from memory. Now in MATLAB, often the command is just what you think it is. So the command here is clear. And if there was a variable here, let's say A is 1, B is 2, C is A plus B, you can see if I put clear, it will get rid of those variables. I'm also going to say CLC, which stands for clear the screen. So if I was to have CLC there, now what I'm going to do is just going to run that, but it's always good practice to do that, is to run the variables so you get rid of everything. You can see it's created a variable called CM, which we'll find out later what that is. Okay, so in the first step, and we're going to do this in each of the 4 practicals, is we're going to create a variable called SID. And in my mind, this stands for site identity. Now, the data that we're going to load from NOAA, each tide gauge site has a number associated with it. And we're going to use battery in New York, and that number is 8518750. Now what I want to do is, I never want to hard code this in. What I'd like to do is, once we've written all the code, I'm just going to change this number and it will do everything for a new site. But that's the site there. Okay, now what we can do now is we want to, so I'm going to go to this website. We'll click on that link, NOAA website. We're going to load that up. Here we go. And what I want to do is scroll down until I see New York. You can either scroll down or you can search it. So here's New York, and there's the battery tide gauge. So let's click on the battery tide gauge there. Okay, now what I'm going to do is go into station information, station home, and you can see there's my ID. Here's a photo of the tide gauge site. I've actually been there in New York. And what you can see here is a latitude and longitude. So the first thing we're going to do is create a variable called lat, which is going to tell us where the latitude is. In a minute, we're going to create a variable called long, which is the longitude. Now, what you can see is we actually want it in decimal degrees. but here the latitude is in degrees and minutes. Now that's quite easy to do. If it's in the north, it's positive. So what I'm going to do is I'm going to go take 40 and I'm going to add it to 42.0, but I'm going to divide by 60 because there's 60 minutes in a degree. We can run this section and you can see, well, I need to do the longitude first. That's why I've got an error. So anytime you get an error, it just says invalid expression, check for missing. It's because I didn't complete this. Now, if it's west, it's negative. So what I'm going to do is 74 plus 0.9 divided by 60. I'm going to put circular brackets around all of them, and because it's west, it's negative. And we can run that, and you can see now we've created a longitude and a latitude, and you can see they're in decimal degrees, as they should be. Okay, now what we're going to do is we are going to plot the location of this data. Now what we're going to do is going to use some built-in coastlines. So there's a function called, well, to load in data you type load, and then MATLAB has a built-in function called coastline. So we're going to run that, and what you can see is it produces a variable called coastal lat and coastal long, and that contains 9,865 values, and that's the global coastline. Okay, what we can then do is type the word figure, and then we're going to use this tile laid out, and you can see I'm just copying from the brackets there. So figure is going to bring in a new figure, and here I just want one row and one column, so I'm only going to have one figure. Later on we can use this to have sort of multiple figures. And then what I'm going to do is type next tile to bring up the first tile. Okay, and what I'm going to do is I'm going to plot the coastal long against the coastal lat, and you can add an extra thing on the end with the color. Here I'm going to go black. I'm going to run that section, and you can see it should produce a figure for me. It's just working, it's a bit slow. Just going to click save. I don't know why it's so slow, but let's just be patient. Okay, so you can see it's plotted a global map there, which is good. Now what I'm going to do is I want to plot another map on there, so I'm going to go plot hold on, and now we can plot the long and the lat. Now this time I'm going to plot a red circle. So let's just run that section again, and now you can see we can zoom in on this plot, but we can see a circle there. And in a minute I'm going to zoom in. Okay, now let's add an X and Y label. Well, in MATLAB it's quite easy. It's just the keyword X label, and then because it's a string, you need quotes, and you can put longitude, degrees, and then we'll add an X label as well, latitude, degrees. If we run that, you can see it will add a longitude and latitude there. We can add a title. What do you think the keyword is? Well, it's really straightforward. It's title. Again, we need a quote, and we're going to put location of battery tide gauge. We can run that, and you can see now we have a quote. We're going to put a box on when you save the figure. This is just a nice way of doing it, and then we're going to put a grid on as well. You can see we've got grid lines there. Now what I want to do is zoom in and just look at North America. So we can actually use a function called xlim. Now, because it's numbers, you need to put it in square brackets there. So I'm going to go from, well, you can choose whatever you want, but I'm going to go from -50 to 50, and then I'm going to set the Y lim as well, and here I'm going to go from 0 to 80. So we can run that, and now you can see we've zoomed in. Now I'm just going to go back up to plot here, and I'm going to change the marker size. There's lots of different properties associated with the plot, and if you look up help, you can see that, but let's go to 20, and you can see that will fill it in and make it larger. You can also add the marker face color. I'm going to make that red. Maybe 20 is a bit large. Let's go for 10, and you can see we've got our point there. Okay, now one final thing I'm going to do is set. Use the set function, and GCA stands for get current access, so whatever is the current access. I'm going to change all of the fonts to bold and all of the font size to 40. And if you run that, you can see I always do that because if I'm going to save a figure for a report or a presentation, it always is clearer and nicer if the font sizes are bigger. Okay, so there you've written your first bit of code to analyze your own data. And you can see it's relatively straightforward. Now, if I had another station, I could just change this and it would update. We'd need to change the longitude and latitude as well. Okay, so now we're going to load in the data. So we're going to go back to this website here, but now we're going to click on water levels. We're going to go into there. And what I want you to do is change a number of things. So first of all, we're going to go to metric, so that it's rather than feet, it's meters. We're going to go for hourly data. I'll change that in a second, but here what we're going to do is we're going to put October. Let me just remember the date. So it's the 29th of October, 28th of October, 2012 is when Hurricane Sandy occurred. And here I'm going to go to October, the last day, 31. We're going to go to hourly, and then we can plot that. And hopefully now you should see a big peak. So you can see that actually the water level should have been around just over 2 meters, but it went to well over 4 meters. So there's a really, really big storm surge there. Now what we can do is we can do show data listing. So here is the data. Just check we've got everything right, and we can export to CSV, which is a comma separated variable. So I'm going to go back here to my downloads, pick up that file, come back here, and now I'm going to pop it into the data folder. Okay, and what I'm going to do is I'm just going to copy that file name. Okay, but you can see the data in that folder there. Okay, so we can go back to our code. So the first thing we're going to do is create a variable called filein, which is the name of the file. Now, if it's a name, really it should always be in quotes. Now, what I want to do is I don't want to hard code this. Okay, because if I hard code it, what I want to do is take this out. So I'm going to put that as quotes. I'm going to go add. I'm going to take this number out, put that in quotes, and here I can add some strings together. But here I defined this earlier, remember, as SID. So you can see up there, SID. So what I'm going to do is just replace this with SID. I'm going to run that section, and now you can see I've created the file name, but it's in a different folder. So I need to add the folder as well. So 2 dots and a backslash means that I actually go back one directory into SOES Practical and then up into the data folder. So I need to go back one, then into the folder called data, and there, and that's our file name there. And again, if I change SID up the top here, run it again, it will automatically create this new file name for me. Okay, the next thing I'm going to do now is read in this data. If you don't know how to do something, just type help read table. So I'd encourage all of you to, if you don't know how to do a function, just type help read table and it will tell you what to do. And you can see here it's told us the format. So I'm going to call it D for data is read table, circular brackets, and it wants the file name, which we can select there as file in. So we can run this section. Equally, if you don't know how to do it, you just type MATLAB read table into Google or whatever you use, and again, there's quite detailed information. They have some examples here as well that you can play around with. So yeah, if you don't know how to do something. Okay, so you can see D equals read table. It's read in this table for me. It's automatically found certain heading names. You can see it's got a date, a time, predicted understroke meter, preliminary, which seems to be empty, and verified. Now I'm pretty sure this is the predicted tide, this is the total water level, because predicted tide is less. So the difference between the two is going to be our storm surge. Okay, so what we're going to do now is the first thing we need to do is change the date. And you can see that the date and time are separate, but we need to put those together. So I've actually given you the code here. So I'm going to say T is string to cat. So I'm changing it from a string array to a category array. I've got so to call a variable, it's the variable name. Remember, I defined it as D. So it's d.date. I'm going to add that to a space, because I want a space between the two, and then d.time. So we can run that and you can have a look at what they are. And you can see it's joined the two together with a space in between. Okay, now we need to use the date time. So I'm going to say TS. I always use TS because for me that time stands for time string. I'm going to do date time, and now I can put in this variable called T, but I need to specify what the input format is. And you can see the input format here, and you have to be quite careful, but it's the year. So we have 4-digit year, we have a backspace or forward space, never know which one. Month is capitals, DD, and then we have hour, minute. So that's the format of the date. Now this now creates a variable called TS, which I can look at here, and here are my dates. You can see they're added together in one nice long string. The data is hourly. Okay, now what we're going to do is within MATLAB, we're going to create a timetable. We're going to call it TT. And timetables are just really nice ways of storing data. Okay, so what we can do is, first of all, we're going to put in the total water level. And this is D dot, and this is the verified row up the top here. So this column here is the water level. Okay, now what we're going to do is put in the predicted tide. So that's D, and the predicted tide is this predicted column here. Okay, and then finally we're going to put in the storm surge. And the storm surge is actually the total water level, so that column there, minus the predicted water level. It's the difference between, so it's also called the non-tidal residual. Now we're going to put in some other functions, but what I'm going to do is put in 3 dots just to get this to another line. All those 3 dots do is get to another line. And you can see now it's got variable 1, variable 2, variable 3. Now it's asking me for the row times. So I put in the keyword row times, and these are stored in TS. I can also put in the variable names. Now these are horrible names here, so let's give it better names. I'm going to put square brackets and I'm going to use double quotes. So the first one is water level, the next one is tide, and then the next one is surge. Okay, and we can run that. I tend to always use shorter names just because then you don't have to do as much typing. Okay, and there is our data. So you can see we have a column of water level, the tide is slightly lower, and this is the surge. And if we zoom through, you should see that we get a very, very big surge of sort of 2.6, 2.8 meters, and we'll plot that in a minute. Okay, so what we can do now is plot the data. So I'm going to use the keyword figure, like we did above, not capital, figure. I'm going to use the tile layout. And here we're going to have two figures. We're going to have 2 rows and 1 column. Okay. Then we're going to type next tile to bring up the first figure. And in the first figure, I'm going to type hold on, so I can plot multiple things on top of each other. But we're going to plot the timetable, and we are going to plot the time in the first column against the water level in the second column, and I'm going to plot this as blue line. I'm going to add another thing at the end, which is the line width, and make that double. And I'm just going to copy that line, and in fact first actually I'm going to plot the tide as red, so I'll change that to TI. Okay, now we can run this and just check that that's working. What have I done? I've spelt it wrong, so you can see always check unrecognized function. If it says an unrecognized function, it's normally the chances are you spelt it wrong. So here you can see I've plotted my first tile. You can see there's no box around it. So what I'm going to do is I'm going to put, in fact, what you could do is go back up to this previous figure that we created, and you could cut and paste the X and Y label if you wanted, save you a bit of time. So the X label is, I'm just going to call it date. The Y label is level in meters. I'm going to put a title. Because there's 2 plots I'm going to use, I'm going to have it as A, water level and predicted tide. I'm going to put a box on. Get used to doing this all the time. A grid on. Okay, so we can run that, and you can see we've got our first nice figure. Now what I'm going to do is just cut and paste this code, and we're going to do our next figure. Now here we only need 1, so I can just cut and paste this code, but here I'm going to plot the surge as green. And I'm going to run that section. Now what I want to do is, I've actually missed a bit of code off here, so I'm just going to add another code. Like I did before, I'm going to do the set function, but now it's slightly different because we've got 2 axes. I'm going to find, GCF stands for get current figure, and all the time to that axis, I'm going to set them as bold, so it'll do it in both figures now. One thing is these figures are a bit small, so I'm just going to go back up to the figure. You can do something else which is called units. I'm going to set the units as being normalized. That just means that the bottom part of my screen is 0, the top is 1, and then I'm going to set the position. And here you need to define 4 digits as a kind of percentage. So I'm going to go 10% along, 10% up. That's where my figure is going to start. It's going to be 80% long and 80% wide. It just means that the figure is much bigger. So you can see it's taken up sort of 80% of the space of this screen. So now you can see the tide should have been less than 2 meters, but because of the hurricane, the sea level was much higher. And on this particular day, we had almost a 3 meter storm surge, which is quite big. Okay. Now we're going to go on to the 6 steps. So you can see actually you've done relatively simple bits of code, but already you've loaded in some quite complex data. You've produced a really nice research quality plot that could go straight into a report or presentation. Okay, now we're going to calculate the height and date and time of the maximum water level. Now in MATLAB, it's quite straightforward. The function is going to be called max, circular brackets, and what we want the maximum of is the timetable, dot, and the water level column. So you always have the function name, circular brackets, what goes in, and then you have square brackets as to what comes out. So what I want out is what the max water level is. Now, if I run this, it tells me that max water level is 4.263 meters, but what I want to do as well is find out, well, which time did that occur? What I can do is I can add a second thing here in max, and you can type help max to look that up. You can see you can have two outputs here. Now this output I'm going to say is RN, which stands for row number of the water level. And what it does is it returns me an index, and it basically says the maximum water level is on row 50. And you can go into TT water level and you can scroll down to line 50, and sure enough there you can see that is the maximum water level. Okay, now in order to get the time, I can go tt.time, and rather than all the time, I just want the time, so circular brackets at row number 1, column 1, or because this is just got a single column, you can do that. So it tells me that the maximum is on the 30th of October, 1 o'clock, and you can see that is right. Now what I'm going to do is copy that, but this time rather than knowing the time, I want to know what the tide was. So I can do tt.ti for tide on that row number. So the water level was 4.2, but actually it should have only been 1.4 meters if there was no weather. Now I can find out what the surge is, change that to SU, and the surge at that time is 2.8 meters. And if you add 2.8 and 1.4, you should get 4.26, which is what we do get there. Okay, now I want to calculate how long was the storm surge above 1 meter in height. Now this is quite easy. What we can do is we can do tt.su greater than 1. And what this does is it actually returns a logical array. You can click in answer here, and this is just 0. So each of those times it's 0, but here now at row 37, you can go into TT and check. Row 37, we start to exceed 1 meter, and here you can see that it goes through and then it goes down again at row 57. So we should see it go back to 0. And then what we can do is just do the sum of all the ones, because this is hourly data. So if we just find out how many hours, so there's 20 hours the surge is above 1 meter, and you can sort of check that, do 1 meter here. Yep, it looks around 20 hours. We can copy this code, now change that to 2. How long was it above 2 hours? It's 7 hours. What I'm going to do is stop there, and I'll record the next bit in a second video.